Hello students, today we are going to understand our chapter number 5 and chapter number 10 in our revision session 8. In revision session 7, we have discussed about chapter number 1 and chapter number 6. So, let's start our chapter number 5, that is periodic classification of element. Some of the questions from chapter number 5 we are going to discuss. Right? Now from chapter number 5 there will be one question of 2 marks and there will be one question of 3 marks. Now if we make a list of the questions of 2 marks and 3 marks, various concepts will be there in front of you. Right? We will try to revise some of the important concepts in this session. So if we take first, so that will be triads of Dobrena. Now, what is triads of Dobrena? Triads of Dobrena. Triads of Dobrena, in that what Dobrena did? Dobrena made group of 3 elements, and that 3 elements were arranged in such a way according to their atomic masses that mass of first element and mass of third elements and average of it is equal to mass of second element. Let's understand it with one example. If we take the group of lithium, sodium and potassium, so what we can say? The atomic mass of lithium, it will be 7 AMU. Atomic mass of sodium, it is 23 AMU, atomic mass unit. And atomic mass of potassium, that is 39 AMU. Now according to triads of Dobrena, this is our first element, this is the second element, and this is the third element. According to this law, what we can say? That the average of first element and third element will be equal to atomic mass of second element. Let's verify it. First element's atomic mass plus third element's atomic mass divided by 2. The first element's atomic mass, here we have taken a group of lithium, sodium and potassium, so that is lithium, so 7, plus third element, that is potassium, that we will get 39 divided by 2. We will get 46 divided by 2. Our answer will be 23 AMU. Now this 23 AMU is the atomic mass of second element. So this way Dobrena has prepared triads of 3 elements in which the atomic mass of second element is average of atomic mass of first element and atomic mass of third element. You can also go through different examples which we have discussed in our regular sessions, and we have also discussed this in our revision sessions. So this question can be asked to you, that triads of Dobrena. You also know that this triad of Dobrena is only applicable for lighter elements, means it is only applicable not for every element, for the lighter elements. So this way triads of Dobrena is our topic which can be asked in exam. This lithium, sodium and potassium, we can also have calcium, strontium and barium, and chlorine, bromine and iodine as a triad of Dobrena. The another important question, that is octave rule of Newland. What comes in octave rule of Newland? According to octave rule of Newland, we can say that at every 8th element the property is repeated, and that is like the notes of music, sa re ga ma pa da ni sa. So after at every 8th element the properties of the elements is repeated, that will come in Newland's law of octaves. We also have the limitations of Newland's law of octave, that it is only applicable for the lighter elements. At that time only 56 elements were discovered, so it is only applicable for the 56 elements. If we see the table of Newland, in that we will have different type of limitations. In that we will see that when it was arranged in the same group, some element were kept, that those who don't have properties similar to the other, like cobalt and nickel. You can go throughout the table of Newland's octave rule and you can verify. So triads of Doberer and octave of Newland is important topic for your exam. Now we will discuss one of the most important topic for 3 marks, that is limitations of Mendeleev's periodic table. Now, in Mendeleev's periodic table, we have studied that there are 4 limitations. The first limitation for that, it is position of hydrogen. In position of hydrogen, what was the limitation? We have learned it, that in some cases hydrogen behaves as a group 1 and group 2 metals. So it behaves as metal, and in some cases hydrogen behaves as group 17 metal. So where to keep that hydrogen? At group 1 or at group 17? That was the problem for Mendeleev. So this is the first limitation, that how to decide the position of hydrogen. So position of hydrogen is the limitation of Mendeleev's periodic table. You can understand that in detail by our revision session and by the worksheet and assignment which you have prepared. The second limitation of it, that is position of isotopes. Now we know what is called isotopes. Isotopes means the elements having same atomic number and different atomic mass. Same atomic number and different atomic mass. Like if we talk about hydrogen, so 1H1, this is normal protein, then it will come 1H2, that's for deuterium, and 1H3, this is tritium. Here you can see that the atomic numbers are same, but the atomic masses are different. So how to arrange this elements, how to arrange this isotopes was limitation of Mendeleev, because Mendeleev periodic table was arranged according to atomic masses. So this was the second limitation of Mendeleev. Then the third limitation of Mendeleev, that is uncertain atomic mass. We all know that Mendeleev's periodic table was arranged according to atomic mass, right? And the increasing of atomic mass was not in a certain manner. So that was also the limitation of Mendeleev's periodic table. And the fourth limitations for Mendeleev periodic table, it was in some cases the higher element was kept before lighter element. In some of the cases, the higher elements were kept before lighter elements, right? So these 4 are limitations of Mendeleev's periodic table. Mendeleev's periodic table works according to increasing of atomic masses. Again, position of hydrogen, position of isotope, uncertain increasing of atomic masses, and in some cases higher elements were kept before the lighter elements. So these were limitations of magnetic periodic table. It can be asked to you in 3 marks. That is most important question. If it is asked in 3 marks, we have to describe how it is the limitation. Means we have to describe about what is problem in defining the position of hydrogen and position of isotope. How that uncertain atomic mass was the limitation, and we have to also give the example how the higher element were kept before the lighter element. Now let's discuss on some of the trends that is in our chapter number 5. In that, first is valency. We know how to find out the valency. If we are talking about group 1, so valency is 1. If we are talking about group 13, so how we can find out the valency? 13 means that will be 2, 8, 3. So the valency will be 3. If we are talking about group 15, so that is 2, 8, 5. We know for octet configuration, here we can donate 5 electron or we can gain 3 electron. So to gain 3 electron will be more preferable. So in this case also our valency will be 3. So how valency works, that already we have learned in the chapter, and that is the base of our standard 9 which we have cleared. So the traits of valency that we have discussed. After that, if we talk about atomic size. See, this atomic size, it also same refers to atomic radius, because as we know that if more radius, so the atomic size will be also more. So what trend we have understood in atomic size or atomic radius? We know that when we move from up to down in group, when we move up to down in group, we know what is group and what is period. The vertical line, that is called group of periodic table, and the horizontal, that is called period. Right? Total we will have 18 group and 7 period in our modern periodic table. So in atomic radius, when we move from up to down, means when the atomic number is increased in group, the atomic size will get increased. So when we will move from up to down, what will happen? The atomic size is increased. So it's simple. When we move from left to right, means when we move from left to right, if up to down it is increased, so left to right it will get decreased. This we have understood. Okay, if we talk about metallic and non-metallic property. So we know at group 1 we are having metals, and at group 17 we are having non-metals. So when we move from left to right, the metallic property is decreasing. So when we move from up to down, it will be opposite. So metallic property will get increased. So here from up to down, what happens to metallic property? It will get increased, and from left to right, the metallic property, it will get decreased. Okay. Also we have another concept, and that is nature of oxides. Now it's simple. As we move from up to down and metallic property increases, we know that metallic properties are basic in nature. So when we move from up to down, the basicity will get increases. So left to right, the basicity will get decreases. So here we can have the concept of metallic or metal oxides, that is basic, and non-metal oxides, that is acidic in nature. So simple. If we merge this both concept, When we move from up to down, the metallic property increases, means that oxide, that basicity will get increased and acidity will get decreased, right? So we have to understand this concept of metal oxides and non-metal oxides with our metallic and non-metallic properties. Again, when we move from up to down, metallic property increases, so metals oxides, they are basic, so basicity will get increased, right, and acidity will get decreased in that term. And the last one, that is electron negativity. Now what happens to electronegativity? When we move from left side to right side. Now what is electronegativity? Electronegativity means tendency to gain electron. Electronegativity means the tendency, the nature to gain electron. And as we know that group 17 can easily gain the electron, so they are more electronegative. And as group 17 is more electronegative, so group 1, that is very less electronegative. So when we move from left side to right side, electronegativity will get increased. So when we move from up to down, the electronegativity, it will get decreased. So when we move from left to right, our electronegativity increase. When we move from up to down, it will become less negative, right? So this way we have discussed some of the traits. These traits can be asked you in blanks, it can be asked you in form of true or false or in form of MCQs, and also it can be asked as 1 marks questions or 2 marks questions. So this way in chapter number 5 we have not taken the whole chapter as a glance, because already in the previous revision session we have understood chapter number 5 with every topics as a detail. Here we have taken only some of the important topics of chapter number 5. Okay, now we will discuss on some of the topics, not every topics, only some of the topics of chapter number 10. That is light, reflection, reflection and refraction. Reflection and refraction. In reflection, if we talk about reflection, so the phenomena of bouncing back of light, that is called reflection. We know the law of reflection, that angle of incident and angle of reflection is always equal. The second law, that ray of incident, normal drawn to the surface, and the reflected ray, that will be in same plane, right? So that two laws of reflection can be asked in 2 marks to you. In this reflection we have understood about how plane mirror forms image. The focal length for plane mirror, that will be infinite. We have also understood about spherical mirrors, right? In that we have understood different definitions of spherical mirrors. So that any of definition can be asked you in 1 marks or in form of blank or in form of match the followings. So in reflection, about types of reflection, in that regular reflection and irregular reflection. Also we have understood about laws of reflection. In laws of refraction we have understood that theta I is equal to theta r in short, and second, incident ray, reflected ray and normal drawn to the surface, this 3 lies in the same plane, that we have understood, right? Also we have understood about plane mirrors and spherical mirrors, right? In this we have understood about concave mirror and convex mirror. Also we have understood about uses of concave mirror and convex mirror, that you can refer for 1 marks or 2 marks of question, also for true or false. One more topic here we have understood about, that was image formation. image formation. Right? In the previous revision session of chapter number 10, we have discussed image formation, and in the regular sessions also we have discussed image formation. So in this session I am not going to explain that image formations in detail, right? Already you have prepared and you have drawn it. You have to do its practice at your home. In that we have to see where the image is from, when the object is kept where, right? So where is your object, where the image we are getting, how the image we are getting, what is nature of that image, that all things we have to understand. In concave mirror we are getting that 6 cases, and in convex mirror we are getting that 2 cases, right? One more thing which we can understand here, and it can be asked in 2 marks, that is magnification. Magnification by mirror. In concept of magnification, what is magnification? We have studied for mirror h dash upon h, ratio of height of image to ratio of height of object, that is considered as magnification. If we want to write this formula in terms of V and U, we can also say that is equal to minus V by U. For mirror, that will be minus V by U. Keep this in your mind. Now, what we can conclude from magnification, that when m is equal to 1, m is greater than 1 and m is less than 1. When m is equal to 1, we will get the equal size of image. When m is greater than 1, we will get enlarged image, and when m is less than 1, we will get diminished image, right? So this question is important for 2 marks, that write about magnification for mirror. So what we can write first, we will write the definition, that magnification is height of image to height of object. So it will be formulated as h dash upon h. It's another formula in terms of V and U, where V is our image distance and U is our object distance. So we will get minus V by U, right? For 3 different cases we are getting this. Now, if the value of m is positive and if the value of m is negative. So if the value of m is positive, we will get virtual and direct image, and if it is negative, we will get real and inverted image, right? So this we have keep in our mind. Different type of MCQs or short questions can be asked from this concepts. Okay, now if we talk about sign convention for mirror and for lens, we are taking this both together because it's an easy concept, only there is a one difference. Here, if I have taken concave mirror, so every distance is taken from pole P. All of the distance are taken from pole P, right? Okay. Here, if we talk about lens, so all of the distance is taken from optical center O. All of the distance is taken from reference of optical center O. Then everything is common here. If you are having positive x direction, so it will be positive. If it is in negative x direction, it will be negative. If it is in positive y direction, means, see, this is our negative x direction. This is our positive x direction in upward direction. So that is positive y. So in that case, it will be positive. And if we talk about downward direction, so that is our negative. So in negative y direction, our term, it will be negative. Similarly, here we will get the same, right? For positive x direction, we are getting the value positive. For negative x direction, we will get the value as negative. For upward direction from the principal axis means that is positive. Y direction, so our value is positive, and if it is in downward side, so that is minus y axis, so at minus y direction we are getting it negative, right? So this way we can understand sign convention for mirror. Here we can say it like this: sign convention for mirror and sign convention for lens. Now let's talk about refraction. Now we know what is called refraction. When light travels from one transparent medium to the another transparent medium, this will be its original position, it will change its direction either towards the normal or away from the normal, right? That we know that from rarer medium to denser medium it will move towards the normal, and from denser medium to rarer medium it will move away from the normal, that we know. So in this case of refraction, we have also understand law of refraction. What we have understood in law of refraction? We have understood that sine of incident angle I to ratio of sine of refracted angle is always constant, and that constant is our eta to 1. Right? This was our first law, and from this we have derived the Snell's law. What we have derived? That sine theta I over sine theta r is equal to eta 2 upon eta 1. So we will get eta 1 sine I is equal to eta 2 sine theta r. Right? So this is our Snell's law. Right here, this will be our theta I, and if we are taking this, so this will be our theta r. This is our eta 1 and this is our eta 2. So refractive index of first medium with the angle sine function is equal to refractive medium of the another medium with function of sine theta r. Right? So this is our Snell's law. Now this eta means our refractive index, and what does this refractive index means? This refractive index means C upon V, where C stands for speed of light in vacuum, and V stands for speed of light in any medium. Right? So this way we have understood our refractive indexes. Right? So here this was our first rule. In second law, the incident ray are refracted ray and the normal drawn to the surface. These three lies in a same plane, that we have understood in our second law of refraction. So this way, this is also the important topic to refer. Now let's understand refraction through glass slab and lateral shift. Now for that we will require a glass slab. Suppose this is our glass slab here. Our glass slab is named as A, B, C and D. This is our eta 1, medium of air, eta 2, medium of glass, and again this eta 3, which is equal to eta 1, that is again medium of air. Now, what happens here? Suppose this is the incident ray. Now, this is normal drawn to the surface. If we think that this incident ray, it is passing out without any type of refraction. Incident ray, it is passing out without any type of refraction. So, it will be somehow like this. Now, what happens? So, when light travels from one transparent medium to another transparent medium, we know it will change its direction. This is rarer medium, this is denser medium, so it will move towards the normal. As it moves towards the normal, here also we can draw a normal. And at last, this ray, this is our denser and this is our rarer medium, so it will emerge out in this way. So it is emerging out in such a way that, now let's see, this is our theta1, this we consider as our theta2, this as theta3 and this as theta4. We are not going on the proof, but we know that this theta1 and theta4 both will be same. So when your theta1 and theta4 both are same, so this both rays, if we name the rays like this, PQ, QR and RS. Suppose this is our ray P, Y, Z. So this P, Q, Y, Z and this ray RS both will be always parallel to each other, and this difference, this perpendicular difference between them, that is called lateral shift. Now, why this shift happened? If we forget about the medium, right, it is changing, so it will be like this. But as we take the medium, so our ray is shifted little bit, right, and that perpendicular distance, that is considered as lateral shift. So this is the important question for 3 marks that explain refraction through glass lamp. So what we have to do, we have to draw the figure, right, and we have to explain the figure that PQ is incident ray for surface AB. As it gets refracted, so QR is refracted ray for surface AB, but incident ray for surface DC. So RS is the refracted ray for surface DC, and that is also our emergent ray. Now, as we can see that both are parallel to each other and the perpendicular distance between our refracted ray, and we have thought the ray which is not being changed its direction, so that is called our lateral shift. So this question can be asked in 3 marks. We have to draw the figure and we have to explain the experiment what we have done. Also we have to write definition of lateral shift, right? So this way you are going to prepare this question, and it is very easy question and very most important for your exam also. Now, as we have studied about magnification for mirror, similarly there will be magnification for lens. Formula is all same regarding to height, but for lens our formula will be M equal to, for lens, M equal to V by U. For mirror, this is for lens, it will be V by U. For mirror, that will be minus V by U. We are not going in proof of it. Also, there is one most important topic that we know, the image formation by lenses, right? In different cases like mirror, there will be 6 cases for convex lens and there will be 2 cases for concave lens. That you are going to do by yourself, that is your self-study. In previous lectures we have explained it, in revision sessions also of chapter 10 we have explained it. So hope you will enjoy that drawing very well. Now, the most important topic, that will be power of lens. It's very simple. Power means what? Power means ability. Power means ability. Ability of lens. Now what lens can do? Lens can converge or it can diverge. Now what is converging lens? So that we know that convex lens is converging, while for diverging we are having concave lens. So how we can define it? The ability of lens to converge or to diverge the light ray, that is called power of lens. Again, the ability of lens to converge or to diverge the light ray, that is called power of lens. And it is observed that if you are having more focal length of lens, so the ability is decreasing. So both are inversely related to each other. So we can say power of lens is 1 upon f. Now what will be unit of this? We can write this is our focal length. Right? This focal length, it can be in meter also and it can be in centimeter also. So according to that, its unit will be 1 upon meter, or we can also call it as meter inverse, and this is also called 1 diopter. What it is called? It's called 1 diopter. Right? So when we can say that 1 diopter power is there, so when our focal length of a lens is 1 meter, so if this is 1 meter, so in that case our power of lens is 1 diopter. Okay. In power of lens also there is two possibilities. It can be positive or it can be negative. When it is positive, if focal length is positive, so power of lens is positive, and that is called convex, and negative, that is called concave lens. Right? So this way we have completed some of the important topics regarding to test of our chapter number 10, that is light, reflection and refraction. Rest other topics we have discussed in our revision sessions, in our regular sessions also. Prepare from your worksheets and from your assignments and be ready for your test. All the very best.